Myself Shampati Sharnokar. I am from the Department of Electronics and Communication Engineering, third year. We are going to study sampling, aliasing, and recontrasting of a continuous time signal. Our input signal is given by xt is equal to sine 2 pi f1 t plus 0.5 sine 2 pi f2 t, where f1 is 50 Hz and f2 is 120 Hz. So the maximum frequency present in our signal is 120 Hz. Therefore, according to the Nyquist sampling theorem, the minimum sampling frequency required should be the twice the maximum frequency, which is 2f max is equal to 240 Hz. In this experiment, we consider three different sampling cases. The first cases use a sampling frequency of 1000 Hz, which is greater than the Nyquist rate. The second class uses 240 Hz, exactly equal to the Nyquist rate, and the third case uses 150 Hz, which is below the Nyquist rate. Reference signal. First, um, first we generate high resolution reference signal, which is represented the original continuous time signal, and the signal contains two frequency components at 50 Hz and 120 Hz, which is amplitude 1 and 0.5 respectively. The reference signal is used for the comparison and sampled and recontrast signal, sampling and reconstruction. Next, we sample the signal and three selected sampling frequencies. After sampling, the signal is recontrasted using ideal sync interpolation. The recontrasting equation is xrt is equal to summation of xn sin c t minus nts by ts, where ts is equal to 1 by fs is the sampling period. The reconstruction error is then calculated by comparing the original reference signal with the recontrasted signal. In the case 1, sampling frequency 1000 Hz. Now coming to the first case, here the sampling frequency is 1000 Hz, which is much greater than the Nyquist rate 240 Hz. Therefore, there is no aliasing. The recontrasted waveform almost completely matches the original waveform. The maximum error is approximately 0.000627 volt, and the RMSE is only about 0.000231 volt. The FFT also shows the original frequency components at 50 Hz and 120 Hz. So this case demonstrates very accurate sampling and reconstruction. Case 2, sampling frequency 240 Hz. Now in the second case, the sampling frequency is exactly 240 Hz, which is equal to the Nyquist rate. According to the theoretical equation condition, this is the minimum sampling frequency of our signal. The system reports no aliasing, but reconstruction quality of poorer because 120 Hz is component lies exactly as fs and Nyquist frequency. The maximum error is approximately 5 0.5055 volt, and the RMSE is around 0.355 volt. So practically, sampling exactly at the Nyquist rate is critical condition, especially for a component lying exactly at the Nyquist frequency. Sampling frequency 150 Hz. Finally, we consider the third case where the sampling frequency is 150 Hz. Since 150 Hz is less than the say, required Nyquist rate of 240 Hz, the sampling condition is violated. Therefore, the aliasing occurs and the 120 Hz component falls back into the observable frequency rate, and the theoretical alias frequency calculated as 120 minus 1 into 150 is 30 Hz. So the original 120 Hz component appears to the 30 Hz component after sampling. This also can be the this also can be clearly observed by the FFT of the sample sequence, where the peaks appear around 30 Hz and 50 Hz. The recontrasted signal is therefore corrupted by aliasing. The maximum reconstruction error is approximately 0.97586 volt, and the RMSE around 0.500 volts. Observation and conclusion, we are about to say, like, from the observation table. From the observation table, from the observation table, we can clearly compare all three cases. For fs greater than 2f max, there is no aliasing and original waveform reconstructed accurately. At fs equal to the 2f max, we are exactly at the Nyquist limit where reconstruction becomes sensitive, and particularly for a frequency component and fs by 2. And for fs less than 2f max, aliasing occurs and the reconstructed waveform becomes distorted. Therefore, the experiment verifies the Nyquist sampling theorem and demonstrates the effect of aliasing and the importance of choosing an appropriate sampling frequency. So, the main conclusion is to avoid aliasing, and sampling frequency should be greater than twice the maximum frequency component of the signal. Thank you.